or S equals 50 km divided by 1 hour. When you do that math, it's really easy, and your speed should be, I was giving you guys time to say it, your speed should be 50 km per hour. Now, you can either write that as 50 km per and then HR for hour, or you guys could do 50 kmph, and I'll know that that is kilometers per hour. Totally up to you. Let's do another one. So, you run 360 meters in 60 seconds. What is your speed? You run 360 meters in 60 seconds. What is your speed? Your speed should be 6 meters per second, 6 mps, or 6 mpers. So hopefully those two examples help you guys a little bit, and we'll go through some more examples and practice problems in here because you will have a speed, distance, and time quiz where I will give you word problems on Socrative, and you're going to have to solve for the correct answer. So, like I said, there are other ways to solve for the missing information. I might say that there is a train traveling at a speed of 500 miles per hour for 20 miles. What is their time? And you would have to solve for that. Or I could ask you, what is the time of a race car driver driving 50 meters at a speed of 100 miles per hour? So you would have to plug those numbers into this formula. And same thing with distance. I could ask you, what is the distance traveled by someone who is driving 60 miles per hour for 6 days? And you just have to solve that. So let's talk about a little easy way to remember all of this. This is something that I have found that every class that has helped everyone at some point. Some people don't like remembering all of these formulas, and they like using the formula triangle. So what you would do is you would draw out this triangle and put an S here, D, and T. So what this triangle is saying is when you are trying to solve for distance right here, you're going to take speed times time. Right here, distance equals speed times time. But if you're looking for time, you're going to take the distance divided by the speed. See, same thing here. Or let's say you're trying to figure out the speed of something. You're going to look right here. Speed equals distance divided by time. So this little line right here, separating distance from everything, is the division sign, or is the dividing line. And then if they're next to each other, you're going to multiply. Hopefully that makes sense. So if you like just knowing the formulas and you can memorize the speed formula right here, the time formula right here, and the distance formula right here, you're totally set. You don't even have to worry about it. But let's say you are not going to be good at remembering those three formulas. You can use the speed, distance, time triangle. And that should help you. So right here, I have the first practice problem, and then the second one, the third one, the fourth one, and the fifth one. I'm not going to read them to you. You can pause this and take your time to go through them, but we are going to review them in our Zoom meeting next week. So I do want you to solve these on your own time, but, just 1 through 5, it's just nice to help you practice and get into the use of using these formulas that I gave you right here. And just so that way you can start getting a little bit into what you're going to have quizzes on and what your test will be on. So let's see, 4, 5. Now, velocity. Velocity is when you know both the speed and the direction of an object's motion. So, when you know both the speed and direction of an object's motion, you are going to know the velocity of an object. So let's look down here. Why is the following phrase velocity? 25 kilometers per hour westward on the freeway. Well, do I know the speed? Yes, you do. It's 25 kilometers per hour. Do you know the direction that the object is traveling? Yeah, right here. It says westward. So you know both the speed and the direction, therefore you know the velocity of this object. If I said a whale was migrating southward at a speed of 5 miles per hour, you would know the velocity of the whale. The direction would be southwards or south, and the speed, I think, was 5 miles per hour. Hopefully that's very simple or pretty easy. Now, graphing motion. This is where it gets hard, and I really wish that I could explain this to you in person. But basically, you can show that an object is moving with a line graph, where you're going to plot distance versus time. So one line will be time and one line will be distance. And then you're also just going to have to know the slope formula. Some of you are in Algebra 1 and this makes sense to you. You have already done this, and some of you are not in Algebra 1 and you have not done this, and you really suck at graphing, and that's okay. We are going to go slow. I'm going to try really, really hard to go slow and help you guys out. So, slope is the rise over the run, and that will make sense once we go to this example. So, right here is a graph that would have been in your notes packet had we been in school, and I printed this out for you. So I'm asking you, what is the slope of a runner? First of all, can you calculate slope from using only points A and B? So point A is right here and point B is right here. Do you think you can calculate the rise over the run of this runner from the points that are already given to you? Yes or no? If you said yes, you are correct. Now, your job is to graph or place a point where the runner is covering a distance of 1,200 meters in 6 minutes. So right here we have time and right here we have distance. Our distance was supposed to be 1,200 meters and it should be a time of 6 minutes. So that would put our next point right here. So along the 6-minute line and along the 1,200 meter line. So your next dot should be right there. So we would calculate the slope of our runner by looking at only 2 of those points and figuring out how much is the rise, what's the amount that they are going up by, and then how much are they going over their run. So if we look at points A and B, the rise from 400 to 800 is what? 400. How do you find that? Well, you take 800 minus 400 and you get 400. So the rise is 400 meters over how long did it take them? So from here to here, you had to go over 1, 2. You had to go over 2 minutes. So the slope of our runner should be m equals 400m divided by 2 minutes, or over 2 minutes. And I give you this. So here is where your point should have been, and then m equals 400 meters over 2 minutes. Sorry that it got cut off. That was a very, very basic baby graph. We aren't gonna do anything much more complicated, just because I can't do it when we're distance learning. I will have some extra challenges for you guys, for those of you that want something more challenging, but a lot of this is going to be focused on a lab that I'm going to have you guys doing at home, and I'll explain it when we get to it. So let's go to the next one. Acceleration. Chapter 2 was all about slow motion. Basically, all you have to know is that some of Earth's plates move at a rate of several centimeters every year, and others will only move a few millimeters per year. Basically, that slow motion is a thing, and it exists. Section 3 is all about acceleration. So let's figure out what it is. Acceleration is the rate at which velocity changes. So the rate at which velocity changes. It can change in two ways, actually. The first change could be direction, and the second change could be speed. Speed can either increase or decrease. So, something that you're going to have to come up with is examples for a change in direction, increase in speed, and decreasing speed. And there is going to be a OneDrive form that I'm going to ask you to fill out with your examples. So, let's think of one together. And when I ask you for an example on the OneDrive forms, your example needs to be different from mine. So, a change in direction. Mozzie could be running at 50 miles per hour. Wow, that's fast. Let's change that. Mozzie could be running 5 miles per hour towards me, but then see a squirrel and decide to run away, or run towards the squirrel. Okay, right there. That's a change in direction. You knew what direction he was traveling. You knew his speed, but then he changed. He went in a whole nother route. Increasing speed. A ambulance could be traveling at 20 miles per hour and go onto the freeway and increase to 60 miles per hour going north. Right there you have velocity. Remember, velocity is the speed and the direction. And you still need that in acceleration. So right there, the ambulance was traveling at 20 miles per hour, and then it hopped on the freeway and ended up going 60 miles per hour, following the speed limit, going northward or northbound. Decreasing speed. A sloth could be moving down a tree at 5 inches per hour and slow down to 1 inch per hour. Okay, that right there is an example of decreasing speed.